So far we have discussed two methods of factorization, that is factorization by the method of common factors. Then we discussed factorization by the method of regrouping. The video links of the tutorials are given in the description box below. And now it's time to discuss factorization using identities. So we have three identities that we discussed earlier. And the three identities are a plus b whole squared is equal to a squared plus b squared plus 2ab. Then a minus b whole squared is equal to a squared plus b squared minus 2ab, and a plus b multiplied by a minus b is equal to a squared minus b squared. These are the three standard identities that we have discussed earlier. Okay, now we have to solve some problems based on these three identities. So we have to factorize. This is x squared plus 8x plus 16. Okay, now if you remember the two methods that we have discussed earlier, that is factorization by regrouping and factorization by common factors, you cannot apply here. If you look at it, this expression properly, you cannot apply those two methods. Then in that case, you have to remember these three identities. If you look at this expression carefully, then it's actually x squared plus, this is 2. First let's write this. So this is x squared, this is 4 squared, and this 8x is 2 multiplied by x multiplied by 4, right? So basically it's what? It's of the form a squared plus 2. This, if you take x as a, then a. If you take 4 as b, then it is 2ab, then this is b squared, right? It's of this form. So this one, a squared plus b squared plus 2ab, that is equal to a plus b whole squared, right? That is, what's x here? Our x is, sorry, what's a here? Our a is x. What's b here? B is 4. So yes, b is 4. So this is x plus 4 whole squared, right? Remember these three identities, and these problems will be a piece of cake for you. Then you have to factorize 4 squared minus 12y plus 9. Now this is 2y whole squared, and this plus 9 is 3 squared, and this minus 12y is minus 2 multiplied by 2y multiplied by 3, right? 2 times 2 is 4, times 3 is 12, and y is here. Now this is of the form, if you take 2y as a, then this is a, this is a squared, then minus 2y is a, so a. If you take 3 as b, then 2ab plus b squared. That is this identity, a squared plus b squared minus 2ab. So you write this as a minus b whole squared. It means that our a is here 2y and b is 3. So this is 2y minus 3 whole squared. This is the required factorization of this expression. In the next one, we have to factorize 49p squared minus 36. Okay, so if you take this first term, 49p squared, this is actually 7p whole squared, right? 7 times 7 is 49, and p squared is p squared, and minus this 36, this term 36 is 6 squared. Now if you take this 7p as a and this as b, then it's actually a squared minus b squared, right? So a squared minus b squared is what? A plus b multiplied by a minus b. So we have taken a as 7p, b as 6, so 7p plus 6 multiplied by 7p minus 6. So this is the required factorization of this 49p squared minus 36. In this case, you have to factorize again, but here you have a squared minus 2ab plus b squared minus c squared. Now this expression, looking at this expression, you cannot relate to one of these three identities, but with a few steps you can relate to this one of these three identities. And how? First focus at this one. So this is basically what? A squared minus 2ab plus b squared, that is this one. So this is a minus b whole squared, and then you have minus c squared. Okay, now let's assume that a minus b is equal to let's say it is x. A minus b is equal to x. Therefore a minus b squared will be x squared. Okay, so let's put at the place of a minus b whole squared, let's put x squared. So x squared minus c squared. Now x squared minus c squared should remind you of this, a squared minus b squared, that is a plus b multiplied by a minus b. So this is x squared minus c squared, that is x plus c multiplied by x minus c. Our x is a minus b, so put here a minus b plus c, then a minus b minus c, right? At the place of x we have put a minus b that we assumed earlier. So this is the required factorization of this algebraic expression.